This is page 30 of the 2018 ACT Review Math portion. So for question 48, we have these two different taxi cabs, and these step graphs below are going to show us how they are charging fare for both cab companies for trips up to 6 miles. And what we are trying to do is compare these companies and find out if we're looking for a 5-mile trip, which one is going to be a cheaper company to go with. So I'm going to start right here for 5 miles. If I go up here and I'm looking straight up to C, you might notice there's an open circle there. Because it's an open circle, that's not actually the defined value for 5 miles. I need you to continue to look up a little bit more, and then I can see the actual cost of the fare for ABC cabs at 5 miles would be $12. If I look at Terry taxi cabs, again, if I'm looking up to 5, I want to be careful here to choose the closed circle, not the open circle. And then if I look across, this one has a height of $9. And what we want is the actual fare for whichever one's cheaper. And so that would be $9, which is option G. Number 49, we have a graph of this function. And what we would like to do is find the area of the region that's bound between these graphs and the x-axis and the y-axis. In other words, we're asked to find the area of this enclosed figure here. Looking at this shape, it's not a shape that I personally am super familiar with, so I would maybe split this up into some shapes that I am more familiar with, and probably shapes that you're familiar with. Squares and rectangles, we tend to do a pretty good job of knowing how to calculate their area, so that's what I'm going to do. I'm going to split this up. Rectangles and triangles, pardon me. This particular rectangle actually does end up being a square. If you look at this ordered pair of 3, 3, that tells you how many units over and how many units up we had to get in order to get to that point. That also tells us the side lengths of this rectangle or square. To find the area of a rectangle or square, you want to do 3 times 3, and that area is 9. I'm guessing that my answer is not going to be 10 in this problem because I still have a couple different shapes, but we'll still calculate it out. For the triangle to the right of that, it also uses that height of 3. Its length on the bottom is 2, and that's because to get to a coordinate of 5, we'd already moved 3 units over to get to the end of the square, and we had to go 2 units past that. The way you find the area of a triangle is 1/2 base times height. And for this triangle, the base and the height are 2 and 3. And when you use your calculator to help with that, we'll find out that that area is 3. So I have an area of 9 and an area of 3, and I still have one more item. I am past that 10. So I do know the answer is not 10. Looking at the top triangle, how far over it is the same as it was on the square. So the base of that triangle is still 3. To calculate the height of the triangle, remember that the rectangle was 3 units above, but this 0.04 is 4 units above. If I subtract them, there's 1 unit left for that triangle. So to find the area of that triangle, absolutely did that wrong. Hang on just a second. This triangle is not going all the way over to 3, 3. It's going to 2, 3. So this base right here is 2. And not 3. My apologies. All right, so the area of this triangle is 1/2 base times height, or 1/2 of 1/2, which is 1. That's our last item that we need to add on, and we end up with an answer of B, 13. Number 50. If I were doing this problem and I were taking the test, I'd probably initially skip this one because it's going to take a little bit of time, to be honest. And you will often feel like you're running out of time on the ACT. So your job is to go through and find the ones that you know how to do and to do those first. And then if you've got time, go back and do the ones that you have a kind of idea about. The ones that you really don't know, and this might be one of those that ends up being like that, or it's going to take a lot of time. You do them to the best of your ability. When there's only like 2 minutes left, pick your favorite letter or placement, because the letters do change from problem to problem, and just bubble that in the same every single time. All right, number 50, we have these two positive numbers, and they're going to add up to 151. The smaller one is 19 more than the square root of the greater one, and we want to find the value of these numbers. I'm just going to call the smaller one x, or the lesser one x, and the one that's a little bit larger I will call y. What I know is that together their sum, or the answer when you add them, is 151. I also know that the smaller one, which I'm calling x, is, this means equals, 19 more than the square root of the greater number. And I want to try to solve this using some algebra here. Well, in my mind, this would probably be the easiest to do if I could rewrite this maybe so that everything is just in one variable. And I don't love the fact that I have that square root of the 19. So the way that I thought about doing it was I moved square root of y. I moved the 19 over to the side with the x. Please notice there's a sign change. And then I squared both sides. When you square both sides, you do want to be really careful with that. On this left-hand side, you're going to have to think of this as x minus 19 times itself and FOIL out or carefully expand out that binomial. When you do that and you combine like terms, you'll get x squared minus 38x plus 361. And that's going to be what y is equal to. So what I ended up doing was taking that expression for y and going back up to the original equation and replacing y with that equation. And I'm going to rewrite that. When I rewrite that, I've had x squared minus 30, I would have x plus, and now I'm going to replace y with this expression in yellow. X squared minus 38x plus 361 equals 151. This is something I decided I would try to solve either by factoring, or if I couldn't figure out how to factor this, then by the quadratic formula. So since I decided to try factoring first, what I decided to do was to rewrite this in descending form and to combine some like terms as I go. And I also am going to move that 151 over to the other side of my equation by subtracting it off. And then I factored it. 210 looks an awful lot like 21. 21 comes from 3 times 7, so 210 would come from 3 times 70, or 30 times 7. I could place that 0 with either one of those factors. 30 and 7 would combine to this negative 37. And so those are the factors that I'm going to choose as I solve this problem. So x is either equal to 30 or x is equal to 7. Now what I'm trying to do is I'm trying to find the value of the difference between these two numbers, the bigger number minus the smaller. What I did each time was I just found the smaller number. That's what we called x. If I want to find the greater number, I can recognize that x and y together are going to add up to 151. So if I subtract that 30 right here off of 151, I can find out what the value of the bigger number is. If I subtract those, their difference here is 151 is not correct. 151 minus 30 would make the bigger number 121. Sorry about that. If I then subtract these numbers, their difference is 91, which is option J. You might wonder about the 7. If I found the y value for 7, which ends up being 144, and I subtract them, those two numbers, the difference is 137, which is another valid answer. It just wasn't the one of the ones they gave us. They gave us only one correct answer there. Number 51. I have these numbers. I like this problem. And I know that the median is 25 and the mode is 15. I want to find the mean. So to find the median is the number in the middle. Now for this particular set of data, I don't know what two of the numbers are, but they appear to be ordered. And that is an assumption that I'm going to go ahead and make here. Also, median is the number that is in the middle when you count in, but this time there's two numbers in the middle. which means the median is the average of those two numbers, or the number that's halfway between those two numbers. So 25 is halfway between 30 and some other number. Well, 25 is 5 units away from 30, and it's also 5 units away from 20. So I'm thinking that 20 is the fifth item in my list. I'm sorry, my fourth item in my list. 25 is not actually in my list. It was just something that I used as the median. The median doesn't actually have to be in the list. All right, the fifth number in my list, I'm going to use the fact that they told us that the mode is 15. Mode is the number that shows up the most often, and in this case, every number only shows up once. So any number that's duplicated is going to be the one that shows up the most often. Since the mode is supposed to be 15, that must mean I have a 15 more than once, and so that other missing number must be 15. From there, I want to go ahead and calculate the average by adding up all of the numbers and dividing by the number of items that we have in the list. So if you add up all of these numbers together, do not include the 25. The 25 was your median and was not an actual data point. But if you add up those other 6 numbers, you get 156, and there are 6 numbers, and the final answer here is 26. Number 52, we have a system. I want there to be more than one solution for this system. More than one solution for the system. Now, looking at the equations, I notice each one has both x's and y's. That's not a very easy way to manage something, so what I decided to do is to take this y value and replace it with x squared, since y is equal to x squared. And I'm going to go ahead and rewrite that equation. Now, at this point, I usually really like to try to factor. However, I can't factor if I don't know numerical values. But what I could do is use the quadratic formula. And what I'm going to use is A, I will replace with S. B, I will replace with R. Note there's a negative b in the equation. And C, I will replace with negative t. Okay, t is a negative value. Oops, there's one more a. Right down there. I'm going to just rewrite this. When I rewrite this, I get, let's see. All right, so I'm going to get negative b, or negative r, plus or minus the square root of r squared minus 4 times the number in the a position, which is s, times c, which is negative t, and I'll divide that by 2 times a, which is s. Now, if I want there to be more than one solution, then what ends up happening is that this number right here needs to be a positive value and needs to then be greater than 0, so positive value. Now right here, a negative times a negative is a positive. So I want this to be greater than 0. And if I look at my answers, although I can't simplify this further, I do have that as one of my answers for F. Number 53, we have the third and fourth terms of an arithmetic sequence are 13 and 18. Arithmetic means we're adding the same amount or subtracting the same amount each time. If I work backwards a little bit, I can find out that the second number must have then been 8. The first number must have been 3. This is your first term right here. That means the 0 term, which can be helpful at times, ends up being 5 less than 3, which is negative 2. This is really a linear function. If I think of it as y equals mx plus b, the slope is the rate of change each time, which is 5. B is the value of the 0 term, or the value of the y-intercept. If I want to find the 50th term, all I have to do is take a 50 and plug it in for x. And when I do that, I end up with 248, which is option A. Last one, number 54 for this page. You can do this two different ways. First thing you can do is take this and put this into your calculator. You're probably going to have to put it in like this. Sine of x quantity squared plus cosine of x quantity squared, and graph this on your graphing calculator, and you get option H. Another way to do this is if you've had trigonometry, you know that there is a trig identity that sine squared plus cosine squared is equal to the value of 1, and that's why we have H as our final answer, since that is the graph of y is equal to 1. And that is it for page 30.